Hello dear student, this part of video will cover the Eview's example which is given on page number 123 to 127 Chris Brooks book of Introductory Financial Econometrics, and the main theme of this particular exercise is that testing of hypothesis in Eviews, and here we are using the CAPM model for the testing of hypothesis. So let's start the open Eviews. So the main purpose of this of this particular example to study the US stock market. So here the author is demanding that you have to create a new work file, and you are using a monthly data, and you have a dated regular frequency, and your data started from January 2002. So for the month you have to write it 1, and 2013 till 2013 4. 04 is mean April month. So click on OK. So you see here we have a two new option will be generated, that is constant and residual. Okay, next he is demanding that you have to see here, you have to import the Excel file of CAPM. So we have to click on file, import, and then import. And I told you that I have put files here. So this is the CAPM. Click on the CAPM, and the procedure of importing will start. Press next, and press next. Brooks is not given these steps now, so that's why these are not given in your book as a you can say as a screenshot. So click OK. Yes. So these are the variables which are given in the Excel form. Now they are in our Eviews file. Okay. Now the main concern, in order to estimate a CAPM equation for the Ford, here we have a Ford company, Ford stock. For example, we need to first transfer the data price series into return. So the Ford data is given in the price, so you have to convert in return, and then excess return. Here we have excess return. So this is our excess return over the risk-free rate. To transfer the series, click on to generate. We have to click on the generate, and now we transfer the series. For this you have to take this formula and paste it in Eviews. We have generated. So see, this is our excess return over the risk-free rate. Now we converting it in R Sandeep. So previously it was send P, and now it is R send P. So click on OK. You can pronounce it R S A N D P. Click on OK. So this is our new file, new variable which is generated with the help of formula, and now it is a lag term also. So the first term is vanished. So this is our lagged variable, because in the formula we use -1. So see here in book, here -1. This means that we are using a lagged, a differenced value. Okay. What the next? And next we will have to rename or generate a new variable, that is R4, will contain the return on Ford. So here is the formula for the R4. So copy this formula and click on generate and then paste it here. So press OK, and now we have a two new variables addition here, r4 and r send p. So see here this same formula is given. Now there are some formulation which Brooks has given, that how can you divide the variable, how can you take the square, how can you take the log, and how can you take the lag, and how can you take the first lag, second lag, and how can you take the difference, and how can you take the difference and log at the same time. These are the formulas which are we go through previously in chapter number 1 as well. Okay, now what's the next? Here Brooks is demanding that you can generate and transfer the new series into the name. If you are transforming the new series with the previous name, then the older series will be overwritten. So that's why you always give the new name to your new variable which you are transforming. So our main concern is that we wanted to find the excess return from the original return series. So here we have to click on generate, and the formula which we have copied, we will paste it, press OK, and then our sandy will be generated. Okay, now what's the next? The next is we have a series of excess return, so we have to convert this series into copy formula and then see the values here first. So it is started from 1.73. So generate, press generate, press paste the formula, and then see this variable is not modifying, so we have to change its name. I am giving it UUSTB. This is our new name, and we are dividing our original variable by 12, so we have to click on OK. So this is our new variable which we have generated. So let's move forward. What the formula he is demanding, that you can find the excess return so that the original return will be remain in the work file. So for this you have to copy this formula, press generate and press Control V, and you are using it a UU. But in case, see here Brooks is giving as minus from the US, but here we generated a new variable, that is UU, because the procedure which we are going to follow here, the same name variable is not generated, so that's why we put it a UUSTB3M. So press OK. After pressing OK, we get ERSANDP, a new variable. Okay, for this we have to generate here the Brooks is saying that you have to generate the same transformation for the R4 return. So we move on, generate, Control V. So here we have to write the formula for the float. So write float. Previous thing will be same, so that's why I am writing as a. Here we have to write R float, ORT, float, and here you see that we have to type a U, so that's the similar thing will be generated. So press OK. Okay, see, we get a new series, a new transformed series here. So Here Brooks is demanding that you can first generate a graph of the CAPM. So we have to generate a graph. So for this he is demanding that go to object and then click on generate a series. I'm sorry, click on object. He is demanding on object, click on object and new object. So see here, click on object, here is the new object, and he is demanding that name it graph 1, GRAPH graph 1. So press OK, and here you have to select the variable whom you are graphing. So first he is using the E4 ER send deep, and D. This is the ER send deep, so double click on it. This will become here. Press space, and the other one E4 ER4. This is the ER4. Press double click, and then this will be come in this window. Okay, here we are graphing it, so press OK. So see, close it. So see here the graph will be generated. So press double click, and you see that the graphical presentation must. Okay, there was a little mistake, so we correct it again. Click object, new object, and then type it a graph 1, GRAPH 1, and here we have to select a graph. So in previous, I'm sorry, I didn't click on the graph, so press OK. So now select the variable ER send deep. This is our first variable. Press space and select the second variable, and this is our E4. So press OK, and see here graph will be generated. So see, this is the same graph which Brooks has given on his book, page number 125. So page number 125, the graph has been given as it is. So see the procedure again. You have to click on the object and then new object, and then select graph and paste the title. Which the title you want to give it, it's depend upon you, but the Brooks is given the title here as a graph 1, so that's why we have given it as a graph 1. So this is normally called the scatter diagram, and you can only here mentioning it as a graph here. Now after the graph we have to test the hypothesis of slope, and as well as, if you like, then constant at the same time. Okay, we have to select the dependent variable here. E4 is dependent variable, and ER send P is independent variable. So you have to select it. Press right click, and then open as equation, and you have to remove C from here to and copy and paste here. So press OK. This is the same screenshot which Brooks has given at page number 126. So before proceeding, we have to see its interpretation, because this is the simple regression model here. So see here, the constant have a negative impact on dependent variable, but here independent variable slope has a positive relationship with the dependent variable. So this reveals that a 1 unit increase in ER, SA and DP 2.026213 unit increase is occurring in our ER4. So now we can test the hypothesis of, here we have a C2 hypothesis of slope, so that's why we have to test this C part or C2. Okay, click on view, coefficient, diagnostics, click on wall coefficient restriction. So which we are going to test, that is C2. So click on is equal to 1. Click OK. So this is our wall statistics outcome, and this screenshot is not given in book, so we have to go through its interpretation as we have gone through by ourselves. So this reveals that our variable have a significant, our slope have a significant relationship with our dependent variable. So this is the main interpretation, and we can also review this interpretation as we have to click on estimates again, and this, see here, slope has positive and significant impact on our dependent variable. So this was the third and last Eview's example of chapter 3. I hope you all understand, and if you feel anything which you can't understand, then you can directly contact me or give me comment in YouTube or in your Google Classroom, which I have given to you. Okay, see you with another video of our this topic and our other topic. Ciao.